Now we're ready to talk about the unit circle, and if you want to go ahead and redraw yours smaller where you have space around the outside, you can. If you did have space around the outside of the one that we did on Tuesday, not necessarily unit circle yet, but it's going to be one, then I would go ahead and use the one from last Tuesday. There are also free templates online of just a unit circle blank template that you could print, or you can print out the worked one, but I think it helps us to go through the process. Okay, so the unit circle is just a circle with a radius of 1. One of the really beautiful things in trig is that really the angles are going to determine what's happening here, and then the ratios are just the same always. So that's what allows us to go ahead and say, if the angles are what's determining everything, we might as well have a side length that is easy to use. So that's why the unit circle, they said, okay, we're going to make the radius 1. And then what we're going to try to figure out is the ordered pair. So we're on a coordinate plane here. We're trying to figure out the ordered pair for every single one of these angles. So for example, the ones that are really easy to do are the ones that are along the x or y axis, because if we're here on the x-axis, I've traveled 1 in the x direction and not up or down, so here's the point 1, 0. At the top we have the point 0, 1. Over here we've got the point -1, 0. And then at the bottom we have our 0, -1. So those are all really easy to see why it works out that way, that those are the points. But anything else is going to be a little tricky. We can guess, or at least estimate in here. We know that all of these numbers are going to be in between 0 and 1 for the x and for the y, because none of them went above this y value and none of them went past this x value either. So they're somewhere in between 0 and 1. But what are they? Which brings us to special right triangles. This is something that you all learned in geometry and revisited in Honors Algebra 3, but it's not something we're going to use a ton. I just want to show you where things are coming from, and then if it's not clicking, I would just throw it out, keep moving. But for special right triangles, they're the 45, 45, 90, which is just talking about its angles, and the 30, 60, 90, which is super helpful for what we're about to talk about, because all of our reference angles are either 30 degrees, 45, or 60. So it has everything that we need. And what we learned in geometry is that in the 45, 45, 90, because it has these two angles that are the same, it's isosceles. So these two legs end up being the same. And then every single time, the hypotenuse ends up being x times radical 2. Every time. So if you want to check that with Pythagorean theorem, you can, but it checks out. It is always going to happen. With the 30, 60, 90, it has a pattern as well. For this one, if our short leg here is x, then our hypotenuse always ends up being 2 times x, and our long leg always ends up being radical 3 times x. Or x times radical 3, I don't know, however you want to write that. Okay, so this is the pattern that we always see. So if we use our pattern on our 3 different cases, the 3 different reference angles we're going to end up with, and keeping in mind that we're talking about the unit circle, so for every single one of these triangles, we want the hypotenuse to be a length of 1. It's going to be the radius. So in this case, the 45, 45, 90, if my hypotenuse is 1, in order to figure out my 2 side lengths, and they're going to be the same, if my 2 sides, my legs, were x, and the hypotenuse was x radical 2, that means to go the opposite direction, I need to divide by radical 2. So I'm going to take my 1 and divide by radical 2. Something that we also learned in geometry and probably used from time to time since then, is that we do need to rationalize this denominator, which just means we don't want there to be a radical in the denominator. So we're going to multiply by whatever that denominator is, radical 2 over radical 2. we're multiplying by 1, so we're allowed to do that. And we're going to get a radical 2 over radical 4, or radical 2 over 2. And that is both of my legs. So I've got a hypotenuse of 1, and then one leg is radical 2 over 2, and this leg is also radical 2 over 2. Okay, so there's the 45. In my 30-degree angle, again, I want my hypotenuse to be 1. And if my hypotenuse is 1, then to go from my hypotenuse to that short leg, I'm going to divide by 2. So my short leg is going to end up being 1/2. And then to go from my short leg to my long leg, I'm going to multiply it by radical 3. So I've got my 1/2 times radical 3. I'm going to get radical 3 over 2. There's my 30-degree angle. You'll notice that the 60-degree angle is going to be really similar because it's still a 30, 60, 90 triangle. I'm still going to have my radius of 1. The only difference here is that it's oriented a little bit differently, and you'll see why I have them this way when we look at the unit circle again. But now, since I have my 60-degree angle down here, my hypotenuse to short leg is going to give me my 1/2. It's going to be below. And then my long leg is going to be that 1/2 times radical 3. So it'll be my radical 3 over 2. So here are the 3 triangles that we're looking at. We're going to make some connections here, so hang in there. If we take our 30-degree, our 30, 60, 90 here, and this isn't going to be perfect because I cut them out, but if we look at that 30-degree angle and our triangle that's created where, notice the hypotenuse is 1 because it's the radius. These legs that we just found, the 1/2 and the radical 3 over 2, are going to tell us what our x and our y are. Because for this point, that means that my x value has gone radical 3 over 2. And my y value is up 1/2. What's really cool with this is that I have a bunch of 30-degree angles. So I'm going to have to flip it, but I've got my 30-degree reference angle over here as well with the 150. So it's going to be really similar, but I have to make sense with the coordinate plane. So my x now is going to be negative. So it'll be a negative radical 3 over 2. And then my y is still positive. So it'll be a positive 1/2. I'm going to have the same thing down here. So I'm going to flip it again. So now my x and my y are both negative, so I've got a negative radical 3 over 2 and a negative 1/2. Notice that my numbers never change, just the signs change. And then my last one, my last 30-degree reference angle, now my x is positive and my y is negative, so I've got my radical 3 over 2 and a negative 1/2. So those are all the 30-degree reference angles. All radical 3 over 2, 1/2. So if we look at our 45-degree reference angle, notice that for this one, the x value is going to be radical 2 over 2, and the y is also going to be radical 2 over 2. Same thing is going to happen that happened with the other one, and I'm not going to go through every single one of these, but I'll go ahead and flip it for the first one. That in this whole quadrant, x is always going to be negative, y is always going to be positive. So I'm going to have that radical 2 over 2, negative radical 2 over 2, radical 2 over 2. Same thing is always going to happen in that third quadrant, that I'm always going to have negative and negative. So a negative radical 2 over 2, negative radical 2 over 2. In the fourth quadrant, I'm always going to have positive and then negative. So I'm going to have my radical 2 over 2 and a negative radical 2 over 2. Okay, and then my last one, our 60-degree angle, reference angle, is going to be the opposite of that 30 degrees since they're both 30, 60, 90s. Now I'm looking at my x value being a 1/2 and my y being a radical 3 over 2. In the second quadrant, I've got a negative 1/2, radical 3 over 2, and The third quadrant, I've got both negatives. And then in the fourth quadrant, I've got just the y being negative. Okay, so I'll zoom out a little bit. And make sure that you have these written down somewhere where you've got every single one of those, and we're going to relate those back to trig.